Hi, welcome back. So previously we talked about this thing called pressure head. Okay, and the equation is H equals to P over rho G. Okay, and how we can, okay, this is also similar to rho G H. So in fact this length, okay, is the pressure head, and how basically we can, from any kind of pressure, okay, as long as you have a value of pressure, you can always convert it to any kind of head, okay, by simply using a density of a certain fluid, okay, dividing it by density and gravity, and then you'll get a certain length of fluid. Alright, so today we're going to talk more about the pressure measuring devices, which you can see on page 18. Okay, primarily there are two main devices which will be introduced to you: the piezometer and the U-tube manometer. The U-tube manometer. Let's talk about piezometer first. Over here it says that piezometer is a device that is used to measure the gauge pressure, okay, of the fluid. So if we turn to page 19, you'll see figure 1-6. A 3D expression of this diagram would be if you have, okay, a pipe with a certain fluid. Let me try to draw it in red. A certain fluid within the pipe flowing. Okay, it is going in a certain direction. So what if you drill a hole here, okay, and you chuck in some sort of an L-shaped tube. So what's going to happen is, if you see from the front, you will get what is shown in figure 1-6. Okay, this is the circumference of the pipe, and you get a tube coming out like this. What's going to happen is that the fluid inside the pipe will of course flow out into the tube and reach a certain level, okay, of certain height. So what this shows is that the pressure inside the pipe has a certain pressure that is higher than what is outside. As you guessed it, what is outside is your atmospheric pressure. So how much higher is it from the atmospheric pressure? If you look at this pressure here, is actually the same as the pressure here. We go by the concept that within a single fluid, any point at the same elevation will have the same pressure. So the pressure here is the same as the pressure here, and the pressure here, let's say this is A. So pressure at A is your atmospheric pressure plus this contribution by this column of fluid, which is the rho G H. Alright, so this is the gauge pressure, okay, at this location. That's what it's trying to say. Alright, so this is piezometer, and what it simply uses is the existing fluid inside the pipe. Okay, it is different from a U-tube manometer in this way. If now I have the same pipe, right? Instead of an L, I take a U-shaped tube. Okay, so I will have the fluid inside the pipe, but I will also have a second fluid, okay, that is called a measuring fluid. And a lot of U-tube manometers use mercury as the measuring fluid, and this sometimes is exposed to air. Let's say it's exposed to atmosphere, so you have your atmospheric pressure over here. And this is exactly the same as figure 1-7. And if you look at this, okay, you need to understand one thing first, and that is the fact is that if depending on the fluid inside the pipe, if the fluid inside the pipe is a gas, alright, if this is a gas, and somehow you are looking at the contribution of the height here, let's say this height H1, and there's another height H2, okay, which we're just comparing, we're not deriving anything, but we're just comparing. So the contribution of pressure by this height of gas, right, will be your rho GH. So rho GH1, and this rho is the density of the gas. But if you look at this this mercury column here, the contribution of this column is effectively rho GH2, and the rho is density. It's mercury. So if you compare between these two, the density of mercury is 13,600, but density of a typical gas, so take for example air, is very small. Okay, so looking at this value comparison, you already know that this column of air, right, will most likely contribute very little to the pressure gauge, to the gauge pressure, compared to what you see over here. Okay, meaning this one can be neglected compared to this one. And what the lecture note is trying to say is that the pressure at here will not have much difference compared to the pressure at here. Okay, which is defining the value of H2. Alright, so if that's the case, right, so let's try to write out the whole equation. Pressure at A. So how do you write the equation? You start off by saying that the pressure at these 2 points are the same. Okay, let me mark it up. Pressure at this point and the pressure at this point are the same, because within the same fluid of mercury, the same elevation gives you the same pressure. Okay, so these two pressure is the same. So what is this pressure over here? It is pressure at A plus rho GH1, and this rho is the gas. Okay, and this pressure is equals to this pressure. So what is the value of this pressure? This pressure is your atmospheric pressure from the top plus this column of mercury. Okay, rho mercury GH2. Okay, this is the full form. But when we say that because this is going to be very insignificant compared to this, you can actually ignore this term and just assume that the pressure at A is similar to the pressure at this location, at this height over here. So that's how you get the expression of this. This is only applied to a situation when the fluid in the pipe is a gas. Okay, so this is basically what it means. We'll stop here and talk about the example next.